sure now.
Watch leads, be advised we're beginning the 950 meter transect now. We're beginning the 950 meter transect. Yes.
Sure. I have you at 45 degrees there, delta of 16.
All right, good copy. Let's get this red guy in the middle rolling.
So Casey's letting us know, I hate to interrupt, but Casey's letting us know we're out of time to discuss this for them. We haven't had a day.
Go ahead, dry lab.
So, would you like me to keep you centered or keep a heading?
You could do both. If that makes any sense.
So
like if
All right, Amanda, while we
if
are
I'm moving way
swapping
off,
things around, can you please
do you want me to follow you?
give us a little bit of background about the
All
Midwater?
right, let's come on out.
Sure. So we're going to be spending the next couple of hours exploring the Midwater environment. Looks like
Let's get this guy right here.
There's a lot of marine snow, so it should be an interesting set of transects. Yeah, this is basically one of the least explored habitats on the planet, despite being quite possibly the largest habitat on the planet. The water column takes up a huge volume of the Earth and has a very abundant fauna that lives at the depths that we'll be looking at.
Now I'm going to come back to port.
So
All right, come on out.
time today for 5 different transects. And the way that we do our exploratory transects on the Okeanos is we spend 10 minutes typically at each of the different depth spins and kind of slowly make our way through the water. And if we see something interesting, we'll
get this floater here.
So we can identify them. And if those on the line don't have the expertise, we get some really nice imagery that we're able to send out to our colleagues elsewhere and
let's let that go.
What's living out here. Often
I'm going to turn more to port because I feel like the current's pushing me to starboard right now.
It's sampled by dragging nets in the water, and when you do that, you don't get to see any of the behavior and orientation of the organism, kind of how they're oriented with relation to each other.
I'm going to turn sideways and move across your screen. If that makes any sense.
Go ahead.
Might need a reminder.
I still have you at 45. Do you want me to look down?
Yeah, you can look down.
Right,
before I showed up here today.
Now let's get this guy right here real quick.
Hey Amanda, it's Stephanie on the line.
All right, coming out.
Hey. Sorry, I just sat down, so I only heard the tail end of what you were saying. But our depths today are 950, 880, 700, 500, and 300. So we've been at 950 for a few minutes now already.
Jelly at the top.
Yeah.
So I think the pilots are waiting for us.
Okay. I'm ready to go whenever you are.
Oh yeah, we were just waiting for the dive call to be over and them to clear out. So should be good now.
Okay.
Watchley, we started the transect at 1941.
Focus on getting the annotations into Describe today.
Now this is Watchley.
Go ahead, Watchley.
Excuse me?
What time did you say?
1941.
I said I'm just going to be focusing most primarily on making sure we get the annotations into
I have
Describe.
The transect at 750, not 700.
So we can just make sure I can either hear the pilot when we start and end each transect. And
I have you at 70.
I'll check in the chat room in case people put IDs in there.
You're almost directly below me.
That's fine.
I see Mike Ford just entered the chat room. I don't know if
right at the top right.
Mike, are you on the line? I don't know if I get.
Okay, coming up. I'm going to push ahead a little bit.
Copy that.
So Amanda,
Yeah.
did you talk about why we're doing the transects at the depths that we're doing them at? Because I may have missed that part if you did.
I haven't, and I would love for you or Adrian to give an overview of that.
Little red guy here, let's get that.
The CCD profile.
Okay, yeah. So on the way down to the seafloor today,
Right,
we
going
had a little bit of a oxygen and temperature anomaly, where we had higher than normal oxygen and lower than normal for that depth temperature, and that started occurring around 880 meters. So we adjusted the depths for our transecting today so that we could take a look at that a little bit more closely, and also the animals that may or may not be associated. Right now it looks like this might be bathylaggid fish like Luroglossus.
Okay,
but Amanda, you would know better than me.
Yeah, if I start drifting up, you gotta let me know too.
Yeah,
I've drifted up quite a bit.
You drifted up about
familiar with what
7
species
meters.
Yeah, I'm gonna come back down.
Copy that.
But it certainly looks like a bathylaggid to me as well. I think that would be a good one to pass on to Tracy.
I'm looking down at you at 86.
Yep, pushing ahead.
But just one thing for the non-scientists out there that may be watching, or hopefully watching, as we go through this transecting process, and hopefully we'll see more fish as well. One of the common body positions that we find fish in is that vertical position with their head down. One of the common escape responses of fish and squid and some other things is to swim down, but also the vertical body positioning means that they have a reduced silhouette. So one of the ways that animals hunt in the water column, where there is very, very limited light, although right now we're at 950 meters, so there is a little bit of downwelling light, so light that's actually coming from the sun through the surface layers of the ocean. And one way that predators hunt for their next meal is to have really large or very sensitive eyes and look upwards. So they're able to detect the silhouette of an animal that's sitting in the water column relative to the very little downwelling light around it. It's one way to avoid being detected by predators that use that method is to try to reduce your silhouette. So a lot of the fish and other animals will position themselves vertically in the water column. Actually, right now, so we're looking at a larvacean, and we saw a few of these yesterday as well. This one's nice, has this nice yellow color, so the animal itself looks a little bit like a tadpole. You can see it flapping the tail portion of its body. And it has two filtering houses. That outer house, which is very transparent, but you can pick it out because it's got all of the large particles stuck to it. That house is a sort of exclusion device, so it's excluding those larger particles from getting into the inner house, which filters out smaller particles, which is then what the animal feeds upon. So that was really cool, nice footage of a larvacean.
I'm looking down at you at 85 degrees.
Yeah, good copy. I'm coming ahead. Let's get this guy as we come by.
And here's another one. It looks very similar, but this one, actually, this is really cool because this one is actually secreting or exuding the inner filter right now. He's pretty close, though, so it's hard to get footage.
Get him on focus.
So these animals, when that outer house gets clogged with particles, they'll just swim out of it and just leave it behind and go somewhere else and extrude another house.
Right, let's move on.
Oh yeah, sorry, Amanda, I just saw your question on the chat. Yes, the The transect, they started at 1941 UTC. So we're almost to the end of the 10-minute transect now.
1931.
1941.
1941. Okay, thank you.
Yeah, sorry about that.
That's okay.
Okay, so now we're going to tilt up the camera to 40-something degrees.
Okay, so we're done with the 950-meter transect.
The main lights?
Yes. I believe it's bank 4.
And we're going to move up to 880 meters.
Starboard mains are
and
off.
that's right around where we were seeing this oxygen and temperature anomaly on the way down earlier in the
tilt
dive.
back up to 45 degrees.
Good. Camera's coming up to 45.
All right, and then when you're, I think we're good there.
45.
Let's start coming up at 10 meters a minute.
Okay. Coming up.
What's our next depth, Nev?
Next depth is 880.
All right.
I have 10
So
meters
one thing I wanted to talk to people out there today is that when we're talking about doing a transect or transecting, it's a very common scientific methodology. People use it in terrestrial ecosystems, freshwater ecosystems, shallow water, marine ecosystems, and we use it in the water column or the midwater as well. And we in the water column, oh, there's a nice, I think it's a solmissus, nice jelly passing by. So when we do a transect in the water column, we go at
so while we're doing this, we want
a set speed for a set amount of time,
15 to 20
and
meter
then
delta.
you can make comparisons between
Sure
different depths.
I don't
so
fly out of the camera view. In this
then if you go for a set
you don't
time
want to adjust the camera
and
unless it's like
a set speed, and you know what
unless
the view of the
we're
camera
into
is,
a
and you
bunch of
don't
current
change
and
the
there's
zoom
nothing I
or
can do about it,
of the
basically.
camera,
I'm just
you
trying
can
to keep
then
myself centered
compare
in
the
camera view.
volume that you went through with the number and
How does
types
the
of
current look at
animals
the
that you
next depth?
saw on that transect.
Yeah, I was just
You
looking
can
at that.
compare
It
that
looks,
over time,
Mostly to the north.
Yeah, there is a
seasons,
spike
years,
to the
etc.
north.
Or you can compare that
fast?
with different depths and look at
Almost
changes in
almost,
biodiversity and biomass in the water column.
0.3 meters per second, so
0.6 knots.
0.6 knots. So we're probably going to want to get the ship moving north.
Okay. Should we go north and east? Looks like there's a 0.2 knot to the east at the same.
Yeah.
So just because I
Best
got
guess.
on the
So northeast.
got on the line a little bit late. Who else is on the line
We're going
besides
to 880,
Amanda?
you said?
880.
880.
I have Adrian in here.
So
as the
should we try a
overstaying
0.3 knot move?
I saw
Maybe that'd be half.
Yeah, if you think
Mike
that.
Ford is in
think that's
the
good.
chat room,
Maybe 0.4.
but I don't believe he's on the line.
All depends on what the ship can do too.
Yeah,
whether
I
it's
saw
pretty
that he
benign
said
out
he's
there
not
right
signed
now.
on.
Okay.
You can
Yes.
probably do that.
Or yet, sorry. Oh, and he did verify that that was solmissus,
Okay.
that jelly that we went past previously.
Right.
What's our
The
next
water
depth?
looks
880.
ridiculously productive.
So we're almost
There's
there.
so
Again,
much
would you like me
marine
to
snow in
pass
here.
that 20 meters? 860
Yeah,
for
and
me?
they were
Yeah, about 15, 20 meters.
the pilots were telling me that was the case when they came through here earlier as part of this sort of anomaly where they went through a layer that
You probably
had
do 15.
denser than normal
Coming up a little
marine
bit faster.
snow.
Bridge, Nav.
Interesting.
Bridge, go
Okay.
No, I
ahead.
mean, you
Like
could
to
probably
request a
See how it
ship
compares with what we
leave it
see
delta
higher
to
up.
15.
Roger.
So
Distance 350 meters.
Yes, we're at 915 meters right now.
Okay,
Bearing.
passing 900.
330 degrees. Speed.
So once
Decimal
we get
3
here,
knots.
just turn on the cameras and we should be
Roger.
good
That
to go.
turn on
is
the
the
range
lights, I mean.
350 meters, bearing 330 degrees,
thicker.
speed decimal 3 knots.
Good copy, Bridge.
not going to be able to see anything pretty soon. Look at this. It's crazy. Yeah, my heading seems to match the current. I'm pointed to the southwest.
ROV nav bridge, move initiated.
Our screen here is a little bit
Turn your heading a little bit.
I was going to say, do you want me to
curious
meet
if
you?
you can tell if this is all marine
Coming
snow,
over
if there's
205,
actual
206.
organisms in here, like little
Looks like your tether's being pushed a little bit.
Yeah, it looks like
Yeah, that's why I'm going that way.
Pixelated.
Okay, so the current is flowing to the southwest, you think?
To the northeast.
Okay, all right. And we're going to move to match it, which
Yes.
is what I just called it.
Yes.
Yeah.
Otherwise, we're going to have a lot of trouble.
Extra current.
Look at this. This is crazy.
Feels like it's snowing.
I've never seen this much marine snow.
If you want, I can throw the Knudsen up on your screen real quick.
Yeah, usually I only see this much marine snow when
We're getting into the
within
thickest part of it right
the
now.
100 or
Just
200
about
meters
another
of the bottom where it's
10
been like
meters,
kicked up
it looks like we'll be
in
completely
high
out
current
of it.
areas.
Yeah, this is crazy.
Okay, passing 880. Continue another 15 past that.
Here it is on,
So
here it
since
is on
we're
your right monitor
seeing so much
momentarily.
marine snow, we can
What's
talk
the
about
far
a
arrow?
little bit
No,
about
I need
what
that
marine
monitor
snow
rolling.
is. And
you need
when
to
we
bring
use that
that back.
term, we're
Yes.
just referring to
Thank you.
all of the particulate material, dead and sinking animal remains, fecal material, mostly produced in the surface waters and
Starting to go up to
slowly
the starboard
sinking
there,
down
pilot.
to the water column. So these are really small particles. They take
Yeah, I'm
a
getting-
long
I'm
time
getting
to
pushed
sink
pretty
down
hard
to.
here.
We're at
After that,
887
Do you want
meters
me to
right
swing
now.
over to meet you? Or?
So wherever you go on the water column, there's a greater or lesser amount
Passing
of marine snow.
870.
And obviously, we're in such a thick layer right now, it's a little bit hard to pick out the actual animals that we might be interested in looking at.
And coming to a slow stop at 865.
Mike's asking about whether or not this thickness or thick layer is marine snow or high
Sitting
or
steady
dense
at
zooplankton.
865.
All right, so turn your
And
heading
it is
to
hard
port.
to tell.
Okay, coming to port.
I think it
Let's come wide on the main
may
camera
be
here,
both,
rolling. Thank you.
but yeah, it's difficult to
And
kind
turn
of assess
mains
that.
back on. You get a chance.
Port and starboard mains coming back on.
All right, keep coming around. What does it look like the current is going? Actually,
So we're at 882 meters, getting set up for the next transect.
looks like it's coming more to your starboard.
Yep.
Turn
I'll
to your
come back.
starboard. Yep.
I think that was a little cyclotony. The full mouth.
Okay, you're
I
starting to
missed
come
it.
out of my
That
view.
was-
Do you want me to follow you? Or?
Yeah, tilt down.
Okay, come down.
Well, there's a dark fish, maybe a myctophid. Yeah, looks like it was myctophid that swam
Yeah,
out.
Got you there at 56
Bottom of the
degrees.
I'm going to
screen
push
there.
out a little bit, and then we'll be good to start this transect. We might have to adjust the ship move here, Andy. There's quite a bit of current.
Okay.
Stuff is flying by, so
Well, there's a nice
the
jelly
opposite
there.
direction I'm going
Possibly halotrephes.
All
is, I
right.
think, where we need to move the ship.
Mike, do you have a
Okay,
guess
so we
on
want
that?
to go northeast.
Yeah. Maybe just adjust this current move, the direction to the northeast.
Will do.
All right.
Okay, maybe like 5-0.
All right. Let's start the transect while we do that.
Alright, copy that. I'm going
Are we
to
still
switch
getting
out
set up
with
here?
Andy, if you're...
Okay, go ahead.
We're about to start. I'll let you know.
Bridge, Nav.
Do you want to try to
Thank
handle
you.
some of these microparticles?
Nav bridge, go ahead.
Could we slowly come about to heading of
Let's get the
50
fish
degrees?
rolling, coming in.
Yep. There's a thing on the left really
Let's
close.
get the
And
fish real
heading
quick.
change to 050.
050I.
Nice. So here we
And we'll have
did
to
for a brief second have a
stop
good view
the
of
position
a
move in order
cyclothony
to.
fish.
Well,
Get
stand by
that guy
just
in
a
the
moment.
top left.
Okay.
Oh, and this might be Amanda's favorite kind of fish, a hatchet fish.
ROV nav
Yay.
bridge. Yeah, I will come to 050. It looks like I can do that without stopping the position move.
Great.
This is
Thank you, Bridge.
sternoptics, right?
Sternoptics, right? That's a really deep cut.
So what are we moving at, Nav?
So for people watching out there,
He just adjusted the ship move.
common name hatchet fish.
So we're doing a
And
long
they
move.
have many
Right now
characteristics
we're
that
at
are good for
330,
hiding in
Okay.
the water
and the ship's
column.
coming about to
They're
050.
laterally flattened, so
We're doing
hopefully
0.3
you saw
knots.
that they are about as thin as a coin. And they have highly mirrored sides. Their scales are like tiny little mirrors. And they also have photophores
This
on
guy right in the
bottom
middle.
side of their body, used to cancel
Right,
out their
mucus coming
silhouette
out.
by creating their own light or bioluminescence. Nav, this is watch 2.
Let's get this guy.
Go ahead, watch 2.
White guy or
I think
the
I might have missed when you
hatchet
said
fish?
the
Something that was
transect started,
flashing
or
right
is
there.
it not?
We just started it now.
It's
Okay,
way in
so
the
at
back.
like
You see it
2001
flashing?
Yeah.
UTC?
Yep.
Okay, thanks.
It's a hatchet fish. I
All right,
think he's
Amanda,
down.
did you hear that?
2001.
Yeah.
Yeah.
Okay.
Hatchet fish. All right, come on out. He's
Yeah,
way
we
out
need
there.
to
Let's get that little guy. Oh,
work
he's
on
down.
making sure that gets communicated.
Camera angle is 60 degrees currently. Can we adjust high pack a little bit, Andy, when you get a chance?
If you go into settings, you can toggle tracking and it'll follow it.
Watch 2, Nav.
I'm going to turn the port a little bit.
Go ahead, Nav.
Yeah, I was a little late on that because I was coordinating with the ship heading change.
No worries. We got it now. Thanks.
You want to try to image some of those microparticles?
You can try. They're going very quick. All right, come on out. I gotta move. Can you tilt down, Andy?
Absolutely.
So, Amanda, what
Coming
do you
down.
think? I guess, Mike, I think, said, maybe
Something
Mike
in
is
the middle.
referring in
Just
his
come in.
chat room comment about the long
Got you right.
strings
80 degrees.
just being snot. Here's a really nice siphonophore. So on the left side are
I'll
the
tilt back with you as you go, and I'll let you
connectors,
know
or
when you
the
need to
swimming
move.
bells.
Copy.
And on the right side, where you see all the opaque tissue, and especially you can actually see a few of those probably very highly stinging tentacles hanging down, leading to the stomachs
getting
of this
closer.
animal. And this one, I
can
would
even
not
see
be
this guy on
surprised
Sirius.
if it's one of them that would actually, if we were able to collect it and bring it to the surface, you would want to put gloves on if you were going to stick your hand anywhere near it. They probably would
All right, let's come in
sting a
as it's
human
swimming.
also.
Gonna swim through.
Yep.
Yeah, so we're
I am
zooming
all the way
in
back
to try
currently.
and get a good look at those
Yeah, good
swimming
copy.
bells, because those
He's
are
turning on
diagnostic
us.
for siphonophores.
All right, I gotta let him go. Come wide.
Go away.
So,
Push
Mike,
out.
did we get enough of you that you could tell what group that is, or genus, or anything?
I gotta push out here, Stephanie.
No worries, thanks. So we're adjusting a little bit compared
ahead.
to the ship because of currents. So we made a little turn
I'll
to
follow
the
you
right.
up.
Yeah, so we're still swinging pilots. We're at 9.5 right now.
Oh, with that
9-5.
changing the direction of the ship move?
Yes.
Oh,
Oh, okay.
We've got looks like a nice red mysid down there that we passed. So a crustacean that lives in the water
If you see
column
something
and
that you like,
feeds
jelly
on
there,
um,
we're passing
particulates.
90
Stop
degrees.
it.
Just a
Come
nice
on in.
jelly. If we could look at that. Oh, this one is Atolla. So the genus Atolla. It's very easy to tell them because they always have that long trailing tentacle.
That's a good shot.
Yes,
hard to focus.
Following you back.
Yeah, it's coming at me
and
very
these
quick.
particular jellies are very bioluminescent.
I'm pulled back.
So they can create their own light if we were able to turn off the lights totally. And if we brushed up against this jelly, you would see this bright blue light going in a ring around the margin of the bell.
Stephanie, what are they doing with that long trailing tentacle?
Following you up.
I was hoping you would not ask me that, however,
Pushing ahead.
because I don't actually know for sure. Perhaps someone knows, but since I'm not a jelly expert, I don't know.
We are back to 9-0.
So when I sailed with Umbari, there was a woman, I don't remember her name, who was doing a project looking at Atolla. And I thought that the hypothesis was that they're using it actually to collect marine snow.
Passing 6-5.
And then kind of bring the tentacle in and feed.
And back to
off
45.
That could be incorrect.
All right.
I mean, it seems plausible, but
Bottom left.
Let's get this guy.
it would be interesting. Why would they only have one tentacle doing that? Right now we're
Very
looking
fast.
at
Ctenophore.
a ctenophore
400.
that just went off the screen below. So a whole separate phylum, Ctenophora, that move around using very tiny rows of cilia, or teen rows.
Oh, pilots. So
And you could see it had two trailing tentacles that they
we're
spread out,
adjusting
and actually
the
those
ship's
have
heading.
Why are we
sticky
adjusting the
cells
ship's
on them. That
Yeah.
is what
So
they
we want to
use
adjust
capture their
the
prey.
ship move.
Yeah.
Okay.
Why? So you asked them to adjust the
Light
ship's
line
heading?
Yes.
left
Oh,
center.
yeah.
Mike,
we
good point. I
did
don't
not
know if
wanna-
I said that particular
did
group
not
of
need to do
ctenophores
that.
are
We
called
wanted to adjust the
side-dipped
ship's move.
Okay.
ctenophores.
The bearing of the ship's move. Sorry, I might have said heading. But
There is also a group of ctenophores called lobate ctenophores.
RV nav
I
bridge.
don't think I've
Go ahead,
seen
Bridge.
one yet today.
Nav, be
But they have very
advised
large
that when we
lobes
come to a
and
heading of 050,
instead of
that
having
will put
trailing
all the
tentacles
forces
like
on
the
the
side-dipped
starboard beam.
ctenophores,
We
Copy that,
have
Bridge.
They move
1 knot
around,
of current and currently
kind of
12
flapping
knots
these
of
large
wind.
lobes.
They'll
Co-
be both on the starboard beam.
Okay. Copy that, Bridge.
you're going to want to bring them back to their good heading.
Yeah, Bridge. So you can
All right,
you can
Mike's
come back
reminded
to
me
your
the name
good
of the
heading
sticky cells that ctenophores
and
use to capture
instead
their prey.
make a bearing change
Coloblasts.
to 050 on the move.
Roger that. Yeah, I can come back to the original heading and then stop the move and start a new one at a new bearing.
Copy that, Bridge.
At our current position
So it
move,
seems,
the thrusters are actually quite happy because
seems
we're
like the
moving,
marine
the forces
snow
are
at
pushing us toward the
880
target.
meters is
Okay.
But if we change the
slightly
target,
less
then
dense
I foresee
than
that it
at
might have,
950 meters.
they might have to work
or maybe
harder.
they're slightly
Okay.
smaller.
Okay, Bridge. Well, as soon as you're
Not
able
sure.
to
What do you-
change the
what's your
bearing,
guys' take
please
on
do
that?
so.
Or is
White
it
reflective
the same
coming to
as
center
the
from
950?
Go ahead.
Thank you, Bridge.
I agree with that. But it
Hey,
seems to be
Nav,
slightly
you
less
might want to
thick
just
here, although
minimize
both
that
pretty
surface
thick.
current because it's definitely throwing
What
us
is
off
that?
because that has not updated
That
in a
looks
couple
like
hours.
another Atolla, just kind of
Okay.
the tentacles are retracted slightly awkwardly, but you can see that one
And I guess while you're at it, could you
trailing
check
tentacle.
that? Well, it looks like the
Actually, it looks
speed
okay.
log is
So
updating, but if they have
it's
a knot of
upside
current,
down, and the main tentacles are
yeah, okay, makes
wrapped
sense.
around the top of the bell. So the
Coming at
trailing
you.
tentacle is upwards. So I don't know if that's
Tilting down with you.
I don't know if that's a normal behavior or if this is a jelly that's
You're
not
heading off to
doing
my
so
starboard.
well.
Yeah, good copy.
Anybody have any ideas on that?
I can turn to keep you in view though if you'd like.
All right, let's come in wide, rolling.
Nav bridge.
Go ahead, Bridge.
What
I've
is the
said great
requested
behavior.
bearing?
The requested bearing is
Could you turn
050.
Turning to face you.
Yeah, I don't
So a position move
recall seeing that before.
bearing 050.
Exactly.
I mean, that
range?
It seems
350
slightly
meters.
out of the ordinary to me,
and the
but
speed is
in
decimal 3.
a three-dimensional
maybe
space,
up here
maybe
with a
it
brighter
doesn't
light.
matter so much which direction you're pointed.
Roger
so
that.
maybe that's
I will
pretty
input
normal.
That
I don't know.
And let you know when it's initiated.
Great. Thank you, Bridge.
We, I think we're done with this transect.
But I was confused at first
so
when we were
Super
coming
said we
upon
can
it.
extend
I
to
didn't
5
realize
minutes.
that it was upside down until we got closer.
Well, let's get this guy real quick.
Yeah, it's pretty odd.
Got you facing back at me currently.
Yep.
So that looks like discarded mucus from
Come wide.
any number of animals. Those two different pieces we just saw.
Watch lead 2, Nav.
Yeah, go ahead.
Down on you.
So, Dive Super looked at the schedule, and it looks like we can go an extra 5 minutes on this depth if you're interested in that.
That line at the bottom. I'm coming to center.
So extend the transect.
That would be great.
Okay.
Let's do that.
We'll
Thank
go
you.
ahead and do that.
Let's get this guy real quick.
Amanda and Adrian, were you able to hear that?
I
don't know if he was on the Okeanos.
No, we couldn't hear that here.
Okay, so we're actually going to extend the transect at 800 meters, but 880 meters, sorry, by 5 minutes.
Oh, wonderful.
I thought you would be okay with that.
Right here in the middle.
Thanks.
Oh, let's see. I can't tell what that doesn't look. It looks like part of an animal. Actually, you know what? No,
ROV
it looks
nav
like
bridge
possibly a piece of
initiated.
sargassum. That's
Still looking
down.
at 70 degrees.
Pushing ahead.
That's cool. That's not
Nav
something I've
bridge.
ever seen in the Pacific.
I would like to change the heading.
Yeah, I don't think I have.
To
I don't think I have
starboard. Is
either.
that,
Well,
This guy real
safe
quick.
wait,
for
we don't
you?
have sargassum
Absolutely,
in the
Bridge.
Pacific,
Go
but
ahead.
I haven't
Roger
seen.
that.
Have you been seeing it out here?
We actually on one of our collections.
Get it in
Yeah,
focus.
we've seen
coming out.
pieces of sargassum a
Shall I
couple
follow you back
times
around?
on the bottom.
Yeah,
I
I'm
don't
going
know
to
if
try
we
to come
saw any
back to
today,
my
but
port.
definitely yesterday.
But
we
keep
saw
me in
some.
view.
I will.
Mm-hmm. Very
I'm
cool.
flying off in that direction right now.
No problem.
Okay, pilots, we started that move at bearing 050.
Yeah, copy that.
Are they moving while they turn their heading?
Yeah, that's fine. They've done that before.
No, I was just checking if they were. I didn't.
They are, yes.
Okay.
So when we were doing our transecting the other day, I don't remember seeing as many of these
Really hot
long,
in here again.
skinny strings of mucus as I am
Want me to
today.
check the vent?
Maybe they're more noticeable today with
The
all
vent
of the
was
marine
partially
snow,
closed
but
earlier today.
I don't
really
recall
hot right now. Come on
noticing
in,
that
video.
so many of them.
Yeah, I mean, we saw a
Let's go.
couple the other day, but I agree there's definitely been much more abundant here.
Okay.
You know, it would be interesting. We don't have a fluorometer on the ROV, but it would be interesting to maybe take a look at some of the satellite imagery and see if this is a more productive area than where we were the other day. There might just be kind of more of
So we've
everything.
got 2 more minutes on
Right.
this transect,
Yeah.
pilots.
More of that
Good copy.
kind of stringy matter.
So there was a,
onto the
that
bottom.
I think was a ketognath, a pink ketognath on the upper left that just wiggled itself around.
White line bottom.
Go for it.
Tilting around to keep you.
It looks like a
Good
string
deal.
of mucus, but there might be something. Looks like there might be something
Going
attached to
underneath
the
the
one
white.
end of it. couldn't tell.
Time to push ahead.
Yeah, pushing ahead.
I just realized I forgot to introduce myself when
I'm going to come back around as you go over to keep you
this is Stephanie Bush.
centered.
I work at the Smithsonian Institution, National Museum of Natural History.
Spin around as you go under to keep you centered.
And if the other people on the line could introduce themselves, which maybe you did do that before, but it's good to do it again.
We really didn't, so
Bobby.
Thank you for that. This is Amanda Netburn. I'm an oceanographer with
That's the end of the 880-meter transect.
Okay, I'm lined up with you.
Yeah, good copy, Andy. All right, I'm going to push out.
That looks like another
Following you up to
Atola.
45.
But I'm heading out to the airport soon.
Thank
so
you.
have a good dive, guys.
Okay.
All right, if you want to kill
Thanks
the
for joining
maze,
us.
Following you up.
So, pilots, it looks like that current is kind of dying down as we ascend.
Are you looking at the ADCP?
Yes.
Cool.
And,
That's just too much movement.
So we might...
I'm moving pretty quick right now.
Okay.
I'm talking to Roland, sorry.
Yeah.
Oh.
Yeah. Go ahead, continue.
So we might maybe just ask the ship to hold position. Right now they're doing a 0.3 knot move.
I leave it up to your discretion, Nav, to try to get us a good speed through water. All right, you ready to head up?
Yes, we're going up 10 meters per minute still?
Yes.
Okay. Ready when you are. Let me know when you
ahead.
want to start. Starting now.
Bridge, Nav.
Nav bridge.
So we
ahead.
finished that
Bridge, would you please come
transect
to an easy stop?
at 2016
Easy stop by.
UTC. I lost my connection to the chat room, so I can't actually note
That's 10 meters
that
per minute.
on there.
What's our
So
next
we
step
finished
now?
one transect at 950 meters.
750.
And we just
Copy.
finished our
10 minutes.
second transect at 880 meters. Now we're going to move up to 700 meters for our next transect. So again, when we are doing a midwater transect,
750.
we're moving through the water column at a set depth for about 10 minutes.
That's
so
what
that
I
we
have
can
on my
compare
spreadsheet.
what
I think
animals
there's
we see at different depths.
miscommunication with Watchley, but
And
I'll double check.
Two transects that we already did run today at 950 meters and 880 meters have been very thick with marine snow. So we'll see when we move up to 700 meters if we have a little bit less dense particulate material in the water.
It's going to go by fast for a second, Roland.
Watch 2, Nav.
Yeah, go ahead.
So I have 750 meters for our next transect. Is that what you have?
That's not what I have. I think 700, 500, and 300 are the transect depths that we always do, and 950 and 880 are the ones that are sort of adjustable.
Okay. All right. So should we go to 700 then instead of 750?
Yes, please.
Okay.
700.
Copy that, pilots?
Yeah.
Copy. 16 minutes.
Hey, Amanda, did you hear that?
I only heard you.
Okay, yeah.
We're not hearing the pilots at all today.
Okay.
Gotcha,
So
Delta
they were
20.
asking, so I had said, our next transect is at 700 meters, and they had on their list that the next one was 750. But I'm pretty sure 700, 500, and 300 are the ones that the depths we always do. Is that correct?
Yeah, that is correct.
Okay, that's what I thought, because, yeah.
Yeah. There's been if there's a really compelling reason to do 750, we can certainly have a discussion with those on the line. But the reason we've been doing it that way is, there's kind of these dual objectives. One is, if we sample at the same, or observe at the same depth everywhere we go, we have some data that we can make comparisons between all the different, dive locations, as well as between different ocean basins, et cetera. But then, of course, when we have some interesting oceanographic or acoustic features, it's nice, you want to do adaptive sampling and see what the fauna look like around those features. So our compromise solution that came out of quite a bit of discussion about this over the last couple of years was to have these 3 depths where we always sample, and then 2 or 3 typically that we can play around with a bit.
Pushing you really fast, pilot?
That's been working out pretty well, but
we're not
we can always
at the target depth right now, so it's going to be hard to tell.
Okay.
But right now, I
Shore
don't
side,
feel
if you
like
guys are not hearing the pilots, you can adjust your balance controls.
I don't feel like there's a ton of
left is full side science only.
Okay, on
right
that ADCP,
pilots only.
it breaks up.
In the middle is both.
At that depth,
Yeah, and
the
but it's
ability
the current's definitely dying down.
Telecom line.
You can try the other channel too.
And what we can do also, Andy,
Yes.
Well, I think
Co-pilot.
we'll just watch it as soon as we get there, and if you see something, feel free to, oh, we should go this way.
Okay.
Got you at a delta of 90 or 09.
Yeah, I see it. A little close.
Still at 45 though.
Yeah.
so. We're at 834 meters right now. This layer of very dense marine snow
Well, we'll
continues.
just have to play it by ear.
There's a little jelly right there.
Jeez, look at how
Too
much
small for me to
snow there is.
identify
That's insane.
beyond jelly
I can't even see the
or
arm
Medusa.
We're going to have to rinse the vehicle down extra well.
Oh, man.
The EK60 on the Knudsen shows we should be clear of that now.
We are not.
Go ahead, watch 2. Okay, we're on our way there now. Yep. Video, so I should latch watch 2 and OKX when I'm talking to watch lead. Okay. Okay.
So Amanda, it's just you at the ECC?
Yeah, Adrian's on her way out. She needs to catch a flight.
Okay.
I can't watch the screen. It makes my eyes bug. That much movement.
We should put the other lights on too.
Oh, God.
Yeah, actually, I don't know how the pilots do it when you guys have to turn, because I just look away with all like the dots going out.
I just look at that screen.
Oh, really? Yeah.
Yeah,
Okay.
when I'm
so
turning.
Similar. Nice.
Yeah.
So we're at 808 meters now, moving up to 700 meters from our last transect, which was at 880 meters. And I'm very curious at what depth we'll get out of this thick layer of marine snow. So we always see this sort of particulate material in the water column, but it's not usually quite this thick or dense. Oh, there's a nice large solmissus.
Cool.
Maybe you guys can describe what's on stream 3, which is the EK60.
Oh yeah, we'll see. Amanda, do you hear that?
Sorry, I didn't hear that.
Roland was asking if you could describe what's on feed 3, which is he put up the EK60.
Oh, sure. So this is acoustic backscatter data. So we have an instrument mounted to the bottom of the ship. And basically what it does is it sends out a ping of sound at really regular intervals and durations. And the sound gets transmitted directly downward through the water column. Every time that there's something in the water that's a different density than water, so pretty much any organism, but particularly anything with hard parts or gas-filled parts with a very different density than water, some of that sound gets reflected back up and is received also by the instrument mounted to the bottom of the ship. Based on how long it takes for that sound to reflect, we know how far away that organism was. So basically what we have going along here is the newest data is coming in on the right-hand side. So as you go to the left, we're going back in time, and you can see the ROV in there slowly making its way up to where we are now.
Yeah, the ADCP is showing at 700 meters about
the data right now are pretty messy.
That'd be wonderful.
So there's a lot of kind of noise from other sources, some interference with other instruments. So this will all get cleaned up after that dive. But we really like to use it for
and we're moving right now.
Our dive planning and interpretation, because we can see where the main of animals are living. So around 500 meters. In the top one is 18 kilohertz. The second one is 38 kilohertz. We can see this thick layer of organisms, and these are, some of the organisms that we're seeing with the ROV, the different fish and shrimp, and the siphonophores have a little gas bubble in them. Many of the siphonophores that we see. So all of those are reflecting some of that sound. We're out here trying to figure out what's in those layers, but also figure out what's outside of some of those layers. So we'll use this.
Oh, yeah, it was insane. Remember this morning.
Yeah, today we have a transect plan for 500 meters, which is right around the core of this layer. But if this layer didn't fall around
it looks like we're just
some of our
now.
plans,
so what is that? That's the oxygen?
we'll often adapt our plan and change
salinity, and O2.
some of those depths.
But which one dropped like
really
that? Temperature rose, right?
Well, depends on which direction you're going. We're ascending right now, so temperature jumped
Would you
up.
like to see the ROV CTD as we're progressing? I don't think you could see that back on shore at the moment.
But oxygen and temperature were
sure, we could take a look at that.
directly correlating.
That's insane.
So you can see it was around 795 meters, I think, that the marine snow got much less dense.
Yeah. You see that?
You're getting kind of far out there.
Yeah, the current dropped way down once we got out of that layer.
Yep.
So, I don't know if you copied that, Stephanie,
like
but the current was
that weird layer
much
is
lower.
somehow kind of entrapping the marine snow. Really interesting.
Yeah, just qualitatively, it appears that the current reduced once we got out of that layer also.
On now, we have switched to our CTD profiles. So on the ROV, we have instruments that measure the density of seawater, the temperature, salinity, or conductivity, which is a proxy for salinity. And those are on the left-hand side. And then we also have an oxygen sensor as well as a turbidity sensor. And our turbidity sensor seems to be a little wonky, or we might need to play around with those ranges, but I don't really see that layer there. But some things to note here are that temperature generally decreases as you go down in the water column. So it's really cold down at the bottom, it's just like if you're boiling water, the warmest water floats the least dense, so it stays up near the surface. Same with salinity, we have the densest water down near the bottom. But we've had a pretty interesting feature here. I haven't had a chance to look at it yet.
That little slash sideways you see there took place as we descended today. And that's right when we got into that very thick layer of marine snow.
Yeah, so there's kind of this weird layer from 800 to 900 meters where there's kind of looks like the water's almost really well mixed, and then there's a really sharp jump in the temperature. I think the density. And then similarly, the oxygen generally will decline with depth, and then at a certain depth it'll start getting higher again. But here again, around 880 meters or so, there's all of a sudden a huge increase in the oxygen. So typically, some kind of submerged feature like this is due to some kind of intrusion of a different water mass, a water that's coming from somewhere else and has really different properties. And we'll have to talk to some Atlantic physical oceanographers and find out if this is, common out here and where this might be coming from. Kind of a new ocean for me.
I'll switch you back to the EK60.
Great. Thank you so much, Owen.
Yeah, thanks for all that input, Amanda. You're much better at talking about that kind of stuff than I am.
I was just about to write in the chat that I kind of have Sunday brain.
Me too, but I have Sunday brain every day I'm at sea, so you can't really tell the difference. So right now we're at 725 meters.
Great, thanks.
Momentarily, I put up the quad split so you can see where we are in the depth with the ROV user interface.
Thanks, video. There was a little Keating gnat or arrow worm in the upper right corner. We're seeing quite a few radiolarians in the water column just now.
10 more meters.
I'll point one out next time. Actually, let's see, no. I think I'm seeing at least 4 or 5 just in the last few meters.
Alright, I'm slowing down. 700. Can we come wide on the Zeus, please?
Mains are back on.
Thank you, Andy. Thank you, co-pilot Andy. Looks like we have a current more to the south, if there's any current.
0.1 maybe?
Coming from the south. Alright, I'm going to push out to 45 in this direction.
Copy. I'll follow you around and center you up.
Do you have the mains back on?
Mains back on.
Once you find a direction, I'll center you up.
I think this looks pretty good. Looking at the particles
So
go
we're
by
at
you.
700
Perfect.
meters now, so we're just getting set up and about to start the transect.
Right, you ready, Andy?
Yep, I'm ready.
Awesome.
Are you?
We're all standing by.
So watch lead, this begins the 700 meter transect.
Thank you. So we just started at 2036 UTC.
Hey, Stephanie and Amanda, this is Mike Ford.
Hi, Mike.
Hi, Mike.
Thanks for joining us.
Yeah.
No sweat. Sorry, I had to just type in those last. I'm looking forward to this one.
Let me know if you see anything rolling.
I was hoping you would join me in the Silver Spring ECC, but I'm glad to have you here, nonetheless.
Been seeing some very
Yeah,
small,
some,
shiny objects
some travel,
as we were almost getting to this area.
Awesome.
Small thing bottom left line.
Looks like all the marine snow went away.
Possible jellies.
Yeah, it went away around, what was it, 790 meters, I think it was. I made a note of it because I knew I wouldn't remember.
Right here in the center.
It was like about 795, 792 where I realized suddenly we could see water, not just particles. Right here we have
down.
Larvasian house. I don't see any animal inside, but they are very tiny, so I might have missed it.
Pushing ahead.
Okay, Dougal says that was an oikoplurid Larvasian. Thanks, Dougal. I'm not very good at Larvasian identification, unless it's a Bathycordius, because they're so large that it's kind of obvious.
Some shiny in the lower left.
Let's get these fish straight ahead.
Centering up on you.
Copy. Move it around too much.
I thought it was interesting that we saw a bunch of.
Are you happy with
radio
this
variants
current pilot?
as we
Or?
came up into this transect. We hadn't seen any previously
Yeah,
in the other
okay.
transect, so pretty cool to see it now.
Yeah, it was like we went through a little patch, but once we got to 700 and started the transect, I haven't seen any.
I would say opposite of if Sirius.
Heating nap up to the right.
Yeah, opposite of Sirius.
Okay.
Maybe start
What's
at
this on
like
the right,
upper right,
pilot?
0.1. Come on in, Ro.
Okay, that looks like another oikoplurid Larvasian.
it's getting very close to
Yeah,
see the
current's coming at us pretty quick.
yeah, they're flying
so
into us
I'll
right now.
back up then.
So I couldn't tell if the animal was still in there or if it had
Let's get
vacated.
this fish right here.
Yeah, that's actually a
That'd be
Ketignath.
45, I believe.
So that's a worm, an
Yeah,
arrow
that's what I
worm.
was going to do.
I'm going to tilt down to keep you in view.
That's a pretty
Yeah,
good
copy
view
that.
of them. We usually
I'll
don't get
do 0.1 knots.
hardly any video of a Ketignath.
Okay, coming up.
9-0.
Bridge nav.
Okay, Dougal, you could tell that it was a discarded house, eh?
Okay, repositioning.
ROV nav bridge.
Bridge, I'd like to request a ship move, range 300
Seems
meters.
like they're not getting lit until they're like right upon
Bearing
us.
045 degrees. speed, 0.1 knots.
Get this guy real quick.
Roger, that is 300 meters, bearing 045
That looks
at
like
0.1 knots.
Potentially part of a molt from suggested shrimp. They have really very long antennae, and sometimes you can tell they're molts because of that. It's like a big partial cloud of mucus on the left there. Pilot, can we look over on the right?
Just went off screen. There you go.
ROV nav bridge, move initiated.
Thank you, Bridge.
So this looks like I think a siphonophore. Yeah, it's a parieid siphonophore. So you can see on the right side, those are the nectophores, or the swimming bells.
This is all the way back.
And then
do we have those
trailing behind
front
that
little lights on or
are
something?
the
it's down low, Roland.
the gastrozoids, or
this
the
whole transect, everything seems
parts of
washed
the
out.
colonial
We
animal
haven't
that have the
changed
guts.
Come wide.
that do
The difference is the
feeding.
snow.
See, it's below me. It's way down there.
We got you going off screen.
Do you guys on the chat room agree that was a parieid?
Yep, that's right, Stephanie. That was a.
So I just
parieid
put in the
siphonophore,
ship
and it's
move
great
for
to,
4.5.
Try to zoom in on that
bearing
swimming bell.
0.45,
The
then
morphology
1/10 of a
of the
knot.
swimming
Good
bell
copy.
is important
I
to
gotta
help
push
us
ahead,
identify
Someone just flew into Sirius
which
this
species
screen.
that might be.
Real nice.
Would you say that the whole colony was shortened from
Following
the
you back
normal
up.
length of a parieid siphonophore?
We are back at
It's
90
tough to
degrees.
tell. It certainly looked like it had sort of a smaller cyphosome than sometimes that we see, but lots of times they break off, and some species are very, very delicate and will break off part of their cyphosome at the bottom. And so we might be seeing kind of a siphonophore that has since broken
Let's get this
off.
down at the bottom.
It had a very simple cyphosome, not a lot of morphology going on underneath that swimming bell, and that's very useful to help us determine which genus, essentially which species that is.
So right now we're looking at a really large discarded house of a larvacean. I'm not sure what species it came from, but it's quite large, and we call those sinkers. So the larvaceans have two houses, which they use to filter particles out of the water column, and once the filters become clogged, the larvacean actually swims out and just leaves the mucus houses behind. And because those mucus houses have collected all the particles, they sink much faster than any given single particle, and reach the sea floor much faster that way. So when we see things like that, we just call them sinkers.
Seems good.
Oh, Diggle, you said that's a Mesocordius house?
Swimming fish, lower center.
Or Mesocordius sinker.
You want to try bumping into point 2?
Yeah, we can try that.
Okay.
Okay, I'll bump it up to point 2.
Seems to be a little better.
Lower fish, lower center.
Get the fish.
Plenty of time here.
All right, that looks like a cyclothone.
Yeah, let's go.
And that's about as much video that you can ever get of those guys. But it's good because we were able to get at least a genus identification. I'm sure someone can tell the species.
Bridge, I'd like to request you to increase the speed.
There's another oikopleurid, actually, and I can see the animal flapping its tail within the inner house or inner filter there.
Let's get this guy off in the distance.
Got you at 60 degrees.
Go ahead.
You're currently
yep, that's a siphonophore.
Here at 705
so
meters.
on the right side is are the swimming bells.
Thank you, Andy.
The nectophores, and the opaque sections are the rest of the colony, the gastrozoids with stomachs, and the reproductive parts.
Near focus.
Okay, come on out.
I have you at 80.
And that looked like it might have been a parieid, although I don't recognize the cyphosome on parieds looking like that. But it didn't. It seemed like it only had 2 nectophores maybe. Mike, did you get a okay look at that to tell?
No, I just had just a little bit of that one, so I didn't catch it all.
Turn around.
But I agree, it's possible. It could have been a Freya's. It certainly looked like a very small set of swimming bells, so it's totally possible.
Oh, here's a nice one.
We have 1 more minute in this transect.
This looks like maybe a Bargmania siphonophore. So you can see it. That's got.
Yeah, this looks much better. Yeah, this is a Thyphonex siphonophore, and it could be Bargmania. So if we can zoom in on the swimming bells, that would be very helpful.
Yeah, it kind of got swirled. I don't know. Your video is probably slightly delayed, but the current is not really allowing us to stop on anything much.
Okay, great.
Have to center back up.
Thanks. I
way off to the
I
side.
put the genus name into the chat room. The best guy.
Okay,
yeah.
Piles, you could combine
Unfortunately,
that with,
I got disconnected from the chat room again, and
complete.
since I'm on Casey's account, I can't sign back in. So sorry about that.
Right,
watch lead nav.
I'm on the phone now.
I will let you come up just a
So
little
that's
bit.
the 700 meter transect complete.
You want to get my lights?
Yep. You want me to wait till we move up or right now?
You can do it now.
Thank you.
So yeah, that was the end at 2046 UTC, Amanda.